In an arithmetic sequence, we keep adding the same amount over and over and over again to get each term. In a geometric sequence, we multiply by the same amount over and over and over again to get each term. So for a couple examples here, if the first term is 6, then I would multiply by 2 to get to 12, multiply by 2 to get to 24, multiply by 2 to get to 48, and so on. And I would keep multiplying by 2 over and over again to get each term. The next one isn't quite as obvious, but this one is I'd multiply by 4/5 to get to 1,000, then multiply by 4/5 to get to 800, then multiply by 4/5, that'll come out to be 640, and I would keep multiplying by 4/5. So the way you can figure this out is just take one term, like say this 1,000 here, and divide by the one that's before it. And you'll see that reduces to 4/5. Anyway, the general nth term of a geometric sequence can be written with the formula of a sub n equal to a sub 1 times r to the n minus 1, where a sub 1 is the first term and r is the common ratio. So for example, a sub 1 is a sub 1 times r to the 0, a sub 18 is a sub 1 times r to the 17th, a sub 100 is a sub 1 times r to the 99th, and so on. So note that that second term has a factor of r times 1, the third term has a factor of r squared, the fourth term has a factor of r cubed, and whatever your term is will have a factor of r times n to the n minus 1. So also note that r is a quotient obtained by taking any term and dividing by the previous term. Alright, so let's say a geometric sequence has a first term of 5 and a common ratio of 3. So that tells me that a sub 1 is 5, a sub 2 is going to be 5 times 3, so 15. A sub 3 is going to be 15 times 3, so 45. A sub 4 would be that 45 times 3, so 120, 135. And a sub 5 would be 135 times 3, so for 435. And so on. If I want to find the ninth term, I could keep doing it this way, but let's go with a formula. A sub n is going to be the first term of 5 times 3 to the n minus 1. So the ninth term is going to be 5 times 3 to the 8th. So I go 5 times 3 to the 8th. I get 32,805. Let's see, if I want to find the first three terms are 16, 4, and 1, and I want to find the seventh term. So I know that a sub 1 is 16, and to find r, I'll take one term and divide by the previous. So I can do 4 divided by 16, which is 1/4, or you can just go 1 divided by 4. All right, that's our r. And that tells me that a sub n is going to be 16 times 1/4 to the n minus 1. And so the seventh term is 16 times 1/4 to the 6. So it looks like a calculator problem. I'll go 16 times 1 divided by 4 to the power of 6. And I end up with 0.00390625. Or see here. Nope. All right, one more example. The first three terms are 3, 6, and 12, so this one's a little bit simpler. My a sub 1 is going to be 3, that's the first term. My r, you can go with 6 over 3, or you can go with 12 over 6, either way. The r is 2. You can see that every time you're multiplying by 2. So a sub n is going to be 3 times 2 to the n minus 1. And so a sub 10 would be 3 times 2 to the 9th. Right? And a calculator, that'd be 3 times 2 to the 9th. And I get 1,536.